Hello, my beautiful computer science students. Welcome to another lesson in AP Computer Science A. We are still in Unit 1, and today we are going to be talking about variables. So this is our Lesson 2, talking about variables in our program, okay, and what they are and how we use them. Okay. So to talk about variables, first we have to talk about something called keywords. Okay. Now, keywords in Java, it means they have a very specific meaning to the compiler, and they can't be used for anything else in a program. Usually your IDE will show them as blue, sometimes another special color. I guess it depends on your IDE. But here's an example of keywords that are shown in blue. So the program we went over in Lesson 1 had several keywords like public, class, static, void, string, and all of those you see are in blue because they have very specific meanings to the compiler. Here are a couple of other common keywords that we're actually going to learn. There's a whole list of them. You could actually look it up online if you wanted to. Just type in Java keywords, a whole list of them. Now, keywords, because they have a specific meaning, they cannot be used as a variable. Okay? And we're going to talk about a variable identifier today. So first, keywords, you can't use them as a variable or as an identifier when you are writing your program. They have a very specific meaning. Okay. Identifier. Okay, besides those keywords, you can create anything to be an identifier in a program. Identifiers are names that identify elements like classes, methods, and variables. So we use the word identifier to kind of encapsulate all of those things. Today we're specifically going to be talking about variables. When we talk about identifiers, they have to obey these rules. They can only be letters, digits, underscores, and dollar signs. Okay. Now letters, it can be uppercase or lowercase. Digits are 0 through 9. An underscore is a special symbol, same thing with the dollar sign. Only those two symbols are allowed in an identifier. You can't have like the @ symbol or the hashtag symbol or the % sign. Like all of those other symbols are not able to be an identifier. Identifiers cannot start with a digit. They can start with a letter, underscore, or dollar sign, but they cannot start with a digit. And it can't be a keyword. Some of the words we just went over, or anything that comes up as blue in your program, in your IDE, it can't be a keyword. You want to make sure your identifier is descriptive in some way, which right now we're not really making useful programs, so it's a little hard to be descriptive when you don't have a useful program. But when we start getting into useful programs, you want to make descriptive identifiers just to make your program easier to read and understand. For example, you could just use X as an identifier, right? You use that all the time in math, just an X. But number of teachers is more descriptive, and it actually tells you what value that variable is going to hold throughout your program. Okay? So it can be anything, but you want to be descriptive where you can be. And also, an important thing to note is that identifiers are case sensitive. So upper and lowercase letters, there is a big difference between them. So if you have 3 different identifiers, area, say that 5 times fast, but you have different letters capitalized, your program will identify those as different identifiers. We usually try to avoid having repeat names just because it can be confusing for a person reading your program, but it's not confusing for the computer. They can identify the difference between them. Okay, so identifiers make up classes, methods, variables. In this lesson, we're specifically going to talk about variables, okay, and kind of what they are and how we might use them in our program. You can think of variables as containers in memory. Okay? They are going to contain something for you in the memory on your computer. When we declare a variable, okay, when we create a variable, we tell the computer to save a space in memory for something that we want to store. We say what the name of the thing will be, and that's where the identifier piece comes in, so that the computer knows how to find that container. It looks up the identifier. Okay? And then we also need to declare what type of thing that container will hold. And that's called a data type. Okay? And Java needs to know what that data type is so it knows how much space to set aside. Okay? Now, how big of a space does it need? Okay. Well, there's actually 8 what we call primitive data types in Java. So primitive data types are data types that are built into a Java program. And each primitive data type needs a different amount of memory space to store whatever value they're going to hold. So you have to declare the type first, followed by the identifier. So you say, okay, this is the type, this is how much space you have to cut out in memory, and then this is what we're going to call that space, so that when I need to go back to that space later, I have the actual identification for it. So let's go over the 8 primitive types, as well as a special type that we also use in Java. Okay, the first one is byte, short, int, and long. Okay, those are the first 4 that we're going to talk about. Byte, short, int, and long. Notice how all of those are lowercase. Okay, byte, short, int, and long. Now the range of values it stores is how big of a space in memory it can hold. So you see byte from -128 to +127. Those are the range of values it stores. And all 4 of these, you see how you get bigger as you go down the list? All 4 of these hold integers. Okay? Only integers can be stored in these data types. Okay? Long being the longest. Okay? So byte has the shortest container, or the smallest container in memory, and it goes all the way up to long, which has the longest container in memory in order to store an integer. Now on the AP exam, they only test you on int. So byte, short, and long, you actually won't see those really anymore in this class. We will specifically focus on int. You can definitely use them in your programs if you so desire, but we're just going to focus on int. The next 2 data types are called float and double. Okay? Again, both lowercase, float and double. And those 2 data types are going to store decimals. Okay? Those store decimal values. And you see float is going to have less of a range than the double data type, which has more of a range. And the AP exam will only test on double. Okay? But you might see float if you ever look online at stuff, so I wanted to bring it up, but we're only going to focus on doubles to hold decimals. The last 3, 2 of them, char and boolean, are both primitive data types. Char holds characters and symbols, anything that's not a letter or a digit, a char can hold. Okay? And a char needs one quotation, one quote on either side to hold a character. Okay? It holds a character. A single character is what it holds. We won't use that in computer science. Boolean holds 3 different types of values: true, false, or null. Null meaning like you don't know. Okay? True, false, or null. And we'll talk about how we use booleans, but that is definitely a type that we will have. So all of those on the screen, those 8, those are considered primitive data types. There's one more data type that is technically not primitive, but it is built into Java that we use. And that's called a string. And you've seen a string before in our first lesson with a string literal. Okay, string literals are stored as strings. It's between quotation marks, and it can store anything between those quotation marks. Letters, digits, symbols, anything between quotation marks. It can contain full pages of books if you wanted to, although I don't recommend that, but it could contain it between quotation marks. It can contain anything. It's not a built-in type. It's not considered a primitive type, but it is available for us to use whenever we need it. These are just specialty variables, and the AP exam will only test on Boolean and string. And we'll see how we use those in programs. It won't test on char. And that's because char, you can represent any character as a string. So we just primarily work with strings. And we can do some cool things with strings that we'll talk about later on too. So we like working with strings. Okay, those are your data types. Okay? 8 primitives, and then we have our string data type. Now, how do we declare it? So we said we needed to declare what data type it is so that Java knew how big of a container it needed. And then we also had to have an identifier with it. Okay? And those 2 things together are declaring a variable. So you start with your data type, space, followed by your variable name, and then your semicolon after that. Okay, and that's declaring a variable. So for practice, I have 4 different segments of code here. Write the code on the line that declares the correct variable. So if we wanted to declare a number to be an integer, we would say int number semicolon. Okay. If we wanted to declare GPA to be a double, we would do double GPA semicolon. Declare answer to be a Boolean variable, Boolean answer semicolon. And declare name to be a string, string name. String is the only data type that is capitalized, okay, capital S. If you use a lowercase s, it will not work. It's a syntax error. Capital S for string. Okay. So you'll have the data type and the variable name that goes with it. So that says, okay, this container in memory, it's going to be called number, and it's going to store an integer. Okay. This container over here, we're going to call it GPA. It's going to store a double. Okay. So on and so forth. Okay. When we declare, we don't actually have any values in them. Okay. We just declare them, and they're there. Okay. If we want to give them a value and actually have the container store a value for them, we get into what's called assigning a variable. Okay. So after you have it, after you've declared it and created that space in memory, then you can actually use the container to store information. Okay. So to change the value of a variable at any point in your program, you use what's called the assignment operator, and that's going to be an equal sign. Okay. The syntax, the variable name goes on the left of the equal sign, and the value goes on the right of the equal sign. And this is what it looks like just as in general. You have your variable name equals expression. And your expression is whatever you want to store in that container. And then you need your semicolon after because this is a statement. Okay. Here I actually want to go over to Replit and show you my declarations here. So I have int number, double GPA, Boolean answer, string name. Okay. So you'll see in Replit, and again, it depends on your IDE, it underlines it just in orange, and it says the value of the variable is not used. Okay. So name is not used. Then it says answer is not used. Okay. That means if I were to try to do like a system.out.print, and let's say I wanted to print number, they're going to tell me that there's an error. In line 7, it says that the variable might not have been initialized, meaning that I never stored anything in number. So this says, system.out.println says, go to the container that's called number, and whatever is in that container, print it to the screen. Okay, but I didn't print anything to the screen. I didn't store anything in container, so it can't print anything to the screen. That's where assigning comes in. So I would use my variable name, number, okay, and I would have it equal to, that's my assignment operator, let's say 5, okay. Number equals 5. So number is the name of my identifier, equals 5. 5 is an integer that I'm going to store in number, okay. So now in that container called number, it's going to have a 5. So now when I run my code, what prints off? It's a 5, okay? Because it goes to the container number, and right above it, I put a 5 into that container, okay? And that's what's happening there. So let's go back to our slides and see a couple more examples of assigning. Okay. Write the code on the line that assigns the value to the correct variable. So assign 5 to number. We just saw that in the program. Okay. Your variable has to go on the left, equals 5. Okay. So visually you can think of, okay, this 5 is going to get stored in the container number. Okay. In the container number. If I wanted to assign 3.9 to GPA, the assignment looks the same. GPA equals 3.9. True to answer. Okay. Answer is a Boolean. Okay, and Boolean can hold true, false, or null without quotation marks. Okay, no quotations. Even though it's a word, you're tempted to use those quotation marks. Don't. Booleans do not use quotations. And then assign your name to name. My name is Kayla, so I put Kayla in quotations and then assign it to name. Okay. When you're using strings and you have a string literal, it always has to be in quotations. Okay. If I were to go back to my Replit screen, let's say I put name equals, and then I'll put my name. Okay. And let's say I wanted to print off name. Okay. Let me go ahead and run this. And you'll see what gets printed off to the screen is the value that's stored in name. Okay. So I said put my name in quotations. I said store that in the variable called name, and then print off what's stored in name. And it'll print off what it is without quotation marks. Okay, without quotations. But you need those quotations. If I didn't have those quotations around my name, I would get a compiler error. Okay, and that's where it says it cannot find symbol. Okay, meaning it doesn't know what this is supposed to be. Okay, so you need quotations in order to be a string literal. Okay, let's go back to our slides here. The last thing we can do, so we declared and initialized, or excuse me, we declared and assigned. The last thing we can do is initialize. And initializing basically means you declare and assign it all on one line. Okay, so what that looks like is declaring and assigning all on one line. So we have our data type, our variable name, equal to whatever we want to store in there. Okay, so in those four containers we had earlier, int number equals 5. Okay, double GPA equals 3.9. So on and so forth. You can do it all on a single line. Okay. Okay, what you need to be careful of though is you can only use a variable and declare it once in a program. Okay, so look, it says a duplicate. Because I've already declared name up here, it does not like that I'm trying to declare it again. Okay, again, you'll get a compiler error if you were to compile this. You can't use the identifier more than once. Okay, it'll tell you this variable name is already defined. Okay, so if I said name 2, that would be fine. Okay, you'll see name 2 is just a different identifier. It still stores Kayla. Okay, I can store the same thing. Two variables can store the same thing, but you cannot have the same identifier. Think of it like, okay, we have these containers in memory, and if they were both called the same thing, the computer would get confused. Okay, this is called name, this is also called name, which one do you want me to use? Okay, it's confusing. So you cannot use the same identifier more than once in a program. Okay, so please watch out for that. Okay. There's also a special initialization that you will see occasionally on the computer science exam. If you have more than 2 or more variables of the same data type, you can just declare that data type once and then assign the values to each variable in the same statement. So let's say I had 2 integers here called number and other num, and they were both integers. I wanted 2 containers of integers. I wanted one called number and one called other num. You can declare it once and then assign number equals 5 and then use a comma to separate the other variable, and that's assignment. Okay. Here's also an example right below it of using a string. Name equals Kayla, comma, middle name equals Jessica, comma, last name equals Smith. I made those last 2 up, but so you can do that. You might see it on the exam. Okay, don't let it throw you off, but it's just a quick way, a shorthand way of creating many variables at a single time. Okay, let's get into concatenation. Okay. Concatenation is where you can merge two string literals together with the symbol plus. In lesson 1, we saw how you can use the plus sign for regular addition. 2 plus 3, you add 2 plus 3, Java's going to print off of 5. Okay. It'll use that as addition because you have two integers. When you have that plus sign between two strings, it's concatenation, and it basically means just push those two things together. It can happen in another string or as a print statement. Okay. And what I mean by that is this. Okay. Here's an example of concatenation being used in two different ways. So I have string name, dog name, that's my variable name, equals Fluffy. Okay. Then I have another string called sentence. Open the quotation marks, your dog's name is, and then notice I have the quotation marks ending here, and then I have plus, and then I have dog name with no quotations around it. Okay. Now, since dog name is a string called Fluffy, okay, what that's going to do is it's going to push your dog's name is and Fluffy together to make one sentence. Sentence in that container called sentence, it now contains the value your dog's name is Fluffy. Okay. And then on the print line statement, you'll see another example of concatenation where it takes that sentence plus and then has an exclamation mark in quotations around it. So a sentence contains your dog's name is Fluffy. So system.println will print your dog's name is Fluffy, and then it'll push together an exclamation mark at the end of it. Okay. So concatenation, two different ways, in a string itself or in a print line statement. Okay. One of the last things we're going to talk about here with variables are size limits. Okay. Each data type has a size limit, and if you try to store a value over that limit, you're going to get an error. Okay. So for example, byte. We talked about how byte was the small integer container and how it can only store values -128 to 127. If you tried to store the value 200 into a byte, you are going to get an error. Okay. And actually, I can show that really quick over in my REPL screen. Okay. Let's say I had a byte number equals 200. Okay. And you can see it's already trying to tell me that I have an issue here. Okay. Incompatible types, okay, is what it's going to say, meaning that 200 was too large. Okay. If I actually had a value that was fine and that I could store in that size limit, I'm not going to get any error message. Okay. Notice how my program runs just fine, no error message to be seen. Okay. So you have to make sure that you're observing those size limits. Okay. You can mix certain data types, but you just really have to be careful about those size limits. Okay. And I'll show you examples of those. So visually, this is always what I like to show. Okay. So here are 4 data types. Obviously, there's 8 plus strings, but here's an example of 4. We have bytes, the smallest, shorts next, int, and then double is actually bigger than int. Double stores more data than an int does. Okay. So when we're talking about size limits, visualize this. Okay. Smaller data types can fit into the larger data types, right? So a byte can fit in a short. Okay. A byte can fit in an int, right? Visualize that red box going into the integer. It can fit into those larger boxes. So an integer can store the value 200, no problem, whereas a byte cannot store the value 200 because it is too small. But anything byte can store, int can also store, right? Byte can store a 50, int can store a 50, etc. But it doesn't work going the opposite way. Larger data types cannot fit into smaller data types. So that means that a double cannot fit into an integer. An integer data type cannot hold a double. and so on and so forth. Okay, something that can fit in an integer isn't necessarily going to be able to fit into a short or a byte. Okay, and let's see examples of what this looks like in code. Okay, so let's focus specifically on int and double because that's what you're really going to see on the exam. A double data type is larger than an integer data type. A double is able to hold an integer. Okay, it can hold an integer because it's larger than an integer. But the vice versa is not true. An integer cannot hold a double type. Okay, so legal and illegal syntax here. Legal would be taking an integer and storing it in a double variable. Okay, so like double value equals 4. Or double number equals 4.0. Okay, both of those are integers, and it's totally legal to store an integer into a double. Okay, you will get no errors. It's illegal for the other way around. If you try to store a 4.5 into an integer, or even a 4.0 into an integer, because a 4.0 is still represented as a decimal, and Java will still read that as a decimal. So that is still illegal. Okay, you cannot do those. You will get a compiler error. So you're able to store doubles, you're able to store integers into doubles, but not doubles into ints. Ooh. The second thing that is kind of common when mixing data types on the exam is strings versus primitives. Okay, again, strings are built in, you kind of use them. After a while, you'll start like feeling like they're primitives, but you got to remember that they're not. Okay, they work a little bit differently. Strings can hold any characters and any number of characters. Okay, it does not limit itself in what it can store. It has to be enclosed in, oh shoot, I'm sorry, I said parentheses here. It has to be enclosed in quotation marks. Okay? It has to be enclosed in quotation marks. And if you mix a string with a primitive, it will result in a string. Okay? String is considered like the largest space in memory, so it can hold anything. But if you mix a string with any primitive, everything will immediately be turned into a string, into the bigger data type. So here's what I mean, and here's some examples of legal and illegal syntax that go with this. Okay. So for example, if I said string A equals quote 5, that's legal. That means in that container A, and that's kind of what I wanted to visualize here on the screen, in that container called A, it's going to hold the value 5. Okay. In double quotes. If I mix data types, so if I say string B equals example plus 5, because this variable is a string, it's going to read that plus as concatenation, and it's going to push those two values together. Example 5 is what it'll be. Excuse me. Same thing if you mix a string with a Boolean. Example plus true, it pushes together into example true. And then even if it went the other way, because it still reads it as a string, true plus example, it'll read the whole thing as a string, true plus example. Okay. All legal syntax, all ways to combine strings and primitives. Here's two examples of illegal syntax. If we had string x equals 5 or string y equals true, both of those, you're trying to put a primitive in a string, and it's going to pop up as an error. You would have to put quotations around them, okay, when they're just by themselves. If it's concatenated with another string, you don't have to, like we saw in this legal syntax over to the left here. But when there's no other string literal in the statement, it's going to pop that up as illegal syntax. Okay. All right, to wrap up here, there's just a few extra notes I want to talk to you about with variables. Again, there's ranges to what your data type can store, the max and the min amount. For integers, okay, because integers are used on the AP exam for integer values, we use what's called a constant in order to access the minimum or the maximum value that an integer can store. So if we wanted to access the smallest integer value, in red right here, this is the constant that we use. Okay, so notice how it's not a number. It's actually going to be an identifier that we use. We'll talk more about constants and these global variables that we're using in Unit 2. For now, I just want to show them to you so that you have seen them, and we'll talk about more ways to use them when we write more interesting programs. Here's an example of how we would define the smallest number that an integer could hold. We would say int, we would label it smallest num, equals, and then instead of actually looking up what the smallest number is, we just use this constant that's already available to us. Same thing with the largest integer value, integer.max underscore value. Okay. That's how we would access the largest integer value. We could also access the smallest double, the largest double, the smallest byte, the largest byte. Like, we can do that, but these are the two most common that you'll see on the AP exam, and you do have to know how to do them. But we'll work more with them throughout our class and see how they can be useful for us. The last two notes here. Again, make sure you use descriptive words for your identifiers. So like here I said int largest num. It's going to hold the largest num. Okay, if I just called it int x, you really, as a programmer, wouldn't quite know what it's supposed to be holding. Be descriptive when you can. And if you noticed, if the identifier consists of several words, we push them together into one, and we use what's called camel case to identify each subsequent word. So for example, if I had an identifier called dog name, which I did, Fluffy, the first one is lowercase, and then the second word that starts with a capital letter, or dog age, or number of dogs. Okay, you'll see that you don't have to use identifiers like that, but you'll see that that's kind of the convention, and that kind of goes along with our good style that we've been talking about, just having good style throughout our Java program. Okay. Thank you so much for watching. That brings us to the end of our computer science lesson. I appreciate you following along up to this point, and I hope you have a great day.